Good day, viewers all over the world. You are welcome to Toydel online class. Today we want to look at further example on zeros of polynomials. Let's consider this example. Find the zeros of the polynomial. What is the polynomial? The polynomial is given as p of x. The polynomial p of x is given as x cubed plus 4x squared plus x minus 6. So how do we know the zeros of this polynomial? We are going to test this by guessing. Guessing is just that you substitute for the value of x that's going to make this polynomial to be equal to 0. What do we do? Let's try. If x equal to 1, if substitute for the value of x equal to 1, are we going to get p of 1 to be equal to 0? If it is yes, then that simply means that x minus 1 is a factor of this polynomial. Let's check it out. That is, let's put x equal to 1 and see if we are going to get 0 at the right hand side. That will be 1 cubed plus 4 into bracket 1 squared plus 1 minus 6. Here will be 1 plus 4 plus 1 minus 6. Then here will be, that will be 6 minus 6 is equal to 0. Oh, since we are able to get 0 when we put x equal to 1, that simply means that x minus 1 is a factor of p of x. That is what I'm trying to say invariably, is that if you use x minus 1 to divide this value of p of x, this polynomial, we are going to get 0 as your remainder. Is a factor. If you use this x minus 1 to divide this, the remainder will be 0, and that is the extension of Remender's theorem, which is called the factor theorem. So from here now we know that x minus 1 is a factor. That is, we have got one of the factors. No, this is x cubed. There are 3 factors that we are going to get from this polynomial. We have got one of the factor by guessing. That is, when we put the value of x. The value of x that is going to make p of x to be equal to 0 is a factor. So x minus 1 is a factor. We will now use x minus 1 to now divide the polynomial. We use x minus 1 to divide the polynomial. The polynomial is what I'm about to write. That is, if I want to do this now, what am I going to use to multiply x that will give me x cubed? That is x squared. X squared times this, x cubed, minus x squared times minus 1 minus x squared. Of course, we introduce the natural negative. This changes to plus. This we cancel out. At the end of the day, we have 5x squared. We bring out plus x. What will I use to multiply x that will give me 5x squared? That is plus 5. 5x. The 5x times x, that's 5x squared, minus 5x. Then we introduce the negative. So this becomes plus. Then this will cancel out. I'm going to have 6x here. Minus 6. Of course, what will I use to multiply x to give me 6x? That's plus 6. Then I'm going to have 6x minus 6. If I introduce minus here we change to plus. At the end of the day, the remainder will be 0. So the remainder will be 0. And that simply means that if I use this divisor to multiply the quotient, I'll get a polynomial. Because the remainder in this case is 0. If you look at that polynomial formula says that divisor times quotient plus remainder. That's the formula. So f of x, which is the polynomial now, this is f of x, which is the polynomial p, is same thing as x cubed plus 4x squared plus 6 minus plus x minus 6 is same thing as you saying divisor x minus 1 multiplied by quotient, the result x squared plus 5x minus 6, then plus the result. In this case, the result is 0 plus 0. So this will vanish out. Then what we are saying invariably is that this polynomial is same thing as this. So if you want to find the zeros of this polynomial, we now say that p of x, the zero of p of x, which is now defined as x minus 1, is equal to x squared plus 5x minus 6 equal to 0. That will be the 0. Just equate the right answer to be 0. This will be the 0. So from here we can have x minus 1. Then of course I can factorize what I have here. This will be x squared. Then this is minus 6. What are the two factors of minus 6? That will give us, that will be minus 6x plus, that will be plus 6x minus x minus 6. That's what we are going to have. So if we find the LCM there, what am I going to get? No, here is plus. I'm sorry. This place is plus, not minus. No, here is plus. So if this is plus, then this is wrong. We are going to have 2x here plus 3x. Then plus 6. That's what I'm going to get. So we do the grouping. When we group the two together, it's equal to 0. We are going to have x minus 1. Then what is common here? X is common. We have x plus 2 there. Then plus 3 is common here. You are going to have x plus 2 equal to 0. That's what you are going to have. Then from there, I can go ahead. From here now, I can move from here and say that I have x minus 1. Then into bracket, I can, this what I have here is what I have here. I can group these two together. Into bracket x plus 2. Then into bracket x plus 3 is equal to 0. This simply means that x minus 1 equals 0, or x plus 2 equals 0, or x plus 3 equals 0. It simply means that x is equal to 1, or x is equal to minus 2, or x is equal to minus 3. So the zeros of the polynomial, the zeros of p of x, the polynomial p of x, are 1, minus 2, and minus 3. So these are the three values which represent the zeros of the polynomial. Or you say the zeros are minus 3, minus 2, and 1. So if you are to find the zeros of the polynomial, just check for the value of x that will make that polynomial to be equal to 0. Once you are able to get that, it simply means that that value, when you now will take it as a factor, will divide that polynomial without remainder. Thank you.